What is up? What is up? Okay. So we'll keep almost an hour because I'm going to actually read a blog about implementing a simple ECS, which is an entity component system. So that's what we're going to do, and I'll just set up everything. hmm Let me just set up everything. Also, by the way, 150 subs on YouTube. Not that I'm one for numbers, not this time, but we will take the win. Not bad at all. And the K6 stream got 200 views or something, which is insane, honestly. So we're taking the win. And I will link the. I don't know if Shashwat's going to come. We'll figure that out later. So let me just see what I'll need. Okay, I have made the announcement. This is there. This is there. Do we need this? Okay. Okay. Mm-hmm. I am a music. Actually, this is an edit. I need good music. I need like something upbeat. I've got my chai ready. We're ready. We're so back. We're so back. Okay. I think I can start sharing my 1 second. Let me just. I was doing something. I was doing something. Also, stream after a long time. I don't think we streamed last week. So, um, MKDR, simple ECS. Okay. Okay. So I think I can share my screen. I think I can share my screen. Oh my god, Daksh, what's up? Refresh. Let's go. Whatever refresh pull means. I have no idea. Let me set up the stuff. But it's been a long time, dude. How are you? Is everything sweet as coconut oil? Coconut oil is not sweet. Smooth as coconut oil. Okay. I think we have everything set up. Okay, so this is what I want to implement today, or at least most of it, which is a simple entity component system. Okay, okay, yeah, okay. Also, I'm confused. Should I switch on the fan? I think let's switch on the fan. Yeah, 1 second. All right. Yeah, we're back. We're so back. We're so back. Okay, we'll code for about an hour, and then see how far we get. The point is to understand, right? And I should get my alarm for 10 o'clock has rung because I have to sleep, but we are not sleeping. We're coding, and then I'm going to watch Attack on Titan after this because that's what something I recently got into. So let me just take out my notebook. Hmm. Yes, sir. Yes, sir. I like to make notes usually because like even if I don't keep the notes somewhere, like it like helps imprint it in my brain somewhere. So that's why I personally like, you know, ECS, Austin Modern Blog, right? Okay, so we're gonna implement like code. We're not just gonna like read this. We're gonna actually code stuff. I've got my stuff ready, but it's an empty project. So I think we'll probably do it in TypeScript because like language shouldn't matter. Super well dodgy with career choices, but we'll do well eventually. Love that, dude. How's it going? You seem different though. Which part about me seems different, dude? In a good way? In a bad way? Shit. I am scared now. Dude, so I did touch grass the last week, like lot of it. So I am like socially a bit tired. And then I have plans next week also. And but next week is like I won't count that as socializing because almost like family. In fact, like family only. So like there's a lot of touching grass. This month has been hectic. A lot has happened this month, both like personal and professional. So I'm a bit tired in that sense. Good way, cutting phase. What you think I've gotten thinner? No, dude, I'm trying to. I'm trying to eat more. Shit. It's like one of those memes. The worst thing you can say to someone who's bulking is, "Hey, dude, good cut." Not that I'm like actively bulking, but like I think more or less I'm eating more. But it's that's fair. Okay, we will eat more peanut butter. That's fine. Okay, but if it looks nice, no complaining. It's fine. It's fine. We recovered. We recovered. We have chai with us. It's fine. All right. But wait, what dodgy with career choices? What's up? Oh, I remember you mentioned something some बहुत पहले, no? Yeah. But like I hope everything's okay. Like, we're still what is the thing? We're still balling anyways, gang. We still ball anyways, gang. Are we still balling anyways, gang? Is that's the question? I've stopped having sugar in my chai, and my will to live is also gone. It tastes so, but you still have to drink it. Hmm. Even in the office, we're just yapping for now. Okay, it's fine. We'll yap for a bit. Even in the office, when I go and like before I would put sugar. Right now, I've stopped having sugar. So like right now, if I take a sip, I'll cringe a bit. Like it's like visibly, I'm like Um, so people in the office will be like, "Is the tea bad today? Like, is the tea not good?" And I'm like, "No, no, tea is good. I just am having it without sugar, and I am willingly putting myself through that pain." So might get, but tea without sugar is greater than tea with sugar. Health benefits wise, sure. Because thing is, I did. So I was having at night. Usually, I would have like Horlicks with milk, but then one of my colleagues said that Horlicks is like extremely unhealthy, and I was like, oh shit, I didn't think about that. So I was like, okay, let's cut back on Horlicks because I would like have it every night as like a routine, right? So turns out it's unhealthy. I was like, okay, fine, we let go of that, and then I'm cutting out sugar just for like personal reasons, and but it's like a strong personal reason. So it's not like I'm having to do it; I'm choosing to do it. So might get max to max couple of months, then you won't like tea with sugar afterwards. Really, dude? I don't think there will ever come a day where I don't like chai with sugar. In fact, the I think yesterday night I made cold coffee at home. By the life skill unlocked, I can make cold coffee at home, and I put like 1.5 cups of sugar in that, and it was for two people, not like just one people. Like I filled a glass, put 1 cup of coffee, 1.5 cups of sugar, and then like we did the cup thing here and there, and then like half did. So good, so good. I was like, holy shit, I can't believe I made this cold coffee. Even though it was like just mixing things, but I was like, wow, I can't believe I made this. Like it was such a proud moment. I was like, oh shit, I am capable of something good. It's been a year, I guess, for me, maybe more. Trust me on this one. Okay, I'll take you up on that. We will see after a few months. The thing is, I don't hate it. Like, I dislike it, the taste, but I don't hate it. So I don't mind it. And the thing is, the first day I had it versus now, it's been like almost 2 weeks. So the first day I had it versus now, it's more bearable. So I know it's like a time thing. It's not like oh my god, I can't do it. So plus like there's a thing with taste buds, right? You like eventually adjust to it. So I don't mind it. Okay. Okay. Ever since first hearing about entity component systems and their implications in game development. By the way, the reason I'll give you context, the reason I'm going for like making this blog and whatnot is because one of our crucial components at work is based on ECS, and I'm just coming to and the thing is, I think I've gotten a fairly decent idea of how an ECS works, but I don't like instinctively get it. So even yesterday, today's Thursday, right? No, on Tuesday, there was something. I was talking to one of the interns, and they came up with this thing that they had to do, and I was like, "Oh shit, this is not as simple as it is, because it requires a lot of like you need to deeply understand ECS to be able to do this." And I was like, you know what, we should probably do that. So this is an attempt to understand ECS better, because if I can understand that part of work deeper, then I think it's just a win overall. Plus, ECS is also used in game development, and I think it's just a good approach to know. I know that in general, like ECS is an alternative to inheritance in game development because, like for example, the problem is um, lol. The thing is, ki, let's say I have a dog. Like actually, yeah, sure. Let's say I have a dog, which is a class, right? A class dog. And then I have a class alien. Okay. This inherits from something, let's say class animal, class, I don't know, outsider. Sorry, aliens, you ain't from Earth. But tomorrow, if I want to have what is alien, brother? I need alien. But let's say tomorrow I want to have a alien dog. And the thing about inheritance is you can only inherit from one parent, right? So then you have to do some weird stuff of like mixing these two, and then you get the behavior of this. And the thing is, if you now want a behavior in this, you have to change something here, which might break this thing. Or if you want something only here but not here, it might break that thing because an alien dog will behave different than a normal dog and only an alien. So instead of all of this, someone was like, "Hey, I have an idea. Why don't we make an entity, which we'll call as dog, and then whatever behavior you want, we can attach as a component to that." So that is basically entity component system, and then system is something also that you can attach to it. I think so. It would be something like this. I think. I'm not sure. That's what we're going to find out. So that's it. Oh my God, Tulip, what's up? Long time, dude. How are you? Can't see your screen, brother. Are you joking? Professional streamer, by the way. Professional streamer. Just so you know. Yeah. I deleted the file. Oh, dude. Oh, God. This is the part. Okay, I'll do it again. Basically, you have a class dog. Sorry, you have a class animal, right? This is inherited by a class dog. This is inheritance. Jesus Christ, dude. Uh, then you have what? Outsider. Sorry, aliens. You're an outsider. And this is an alien. Now, tomorrow, if you want to have in your game an alien dog, you have to do some weird stuff over here, right? Because you can only inherit from one parent. So instead of that, someone said that, hey, let's make an entity. Let's call this dog, and you attach a component which defines the behavior of the entity. So that is one, and I think you do attach a system to it, but that's what we're going to find out. Good recap. Good recap. Bila. I'm gonna highlight that. Very true. Very true. I should close the stream right now. Dude. It's fine. Don't need to explain again. Got it. Just want to let it. Thanks. We are co-working. Yeah, we're co-working. I'm going to be coding. So we're going to be coding this blog to understand ECS. And if you're working, let's go, dude. Long time. We missed you in the server, by the way. Honestly, server has gotten a little bit boring without you. I'm being very honest. So, you know. Chalo, let's start. I'm actually going to now start. Okay, ever since first hearing about entity component systems and then implications in game development, I wanted to build one for my own usage and knowledge. Same, brother. Hey, fair. We are boring, no doubt. There are few examples that people have built and posted online, and there are few full-fledged ones that can be used to build real games. I like different aspects of each of them that I studied, but I wanted to build my own and put my own spin on the problem, incorporating different elements from different examples. This is the result. Okay, so we've got the references. Oh, this is interesting. Nomad. Is this a thing on GitHub? Oh, this is interesting. Nomad Game Engine is just a list of articles and a link to GitHub, but eventually it will be a hub for everything to do with the project. Interesting. Anyway, we'll see that later. It is admittedly and by design simple. It is intended as a jumping off point for the curious. We love that. Update. In the 2 years since I wrote this, I've received many comments / emails about it, and it gets a lot of daily hits. I fear that people read it and take it as a gospel when I never intended it to be seen as an authority on the subject. I just want to write about something that I found interesting. Since then, my feelings on a few things have changed. So I'd like to talk about them here briefly. I don't like modern C++ or really C++ in general. Dude, the fact that That is something on, like, to talk about the language on something which is language agnostic is so crazy. Like someone was like, "Oh, do you like C++ now? I read it from your ECS blog." Who cares, bro? Anyway, I'm not an expert on ECSs. Okay. Yeah, yeah. Okay, 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 okay. What is an ECS? Let's go. Let's go. We're so back. Okay, I don't like this song. Listen, we need to lock in. I love this song. Okay. Repeat. Thank you very much. Okay. Traditionally, in game development, you would follow an inheritance approach to problems. A goblin inherits from a monster, which inherits from an actor. A shopkeeper inherits from a human, which also inherits from an actor. The actor class contains a function called render, which knows how to render an actor. So for every goblin, you can call goblin.render, and for every shopkeeper, you can call shopkeeper.render. Correct. Hmm. There are two main problems with this approach. The first is the problem of flexibility. If you decide that you want to visit a town of friendly goblins in the game, and you have goblin shopkeepers, yeah, same example, right? Your functionality in the shopkeeper class, uh, selling, bartering, whatever. Oh, sorry. You have all the, dude, did I just forget how to read? And you have goblin shopkeepers, your inheritance tree gets messed up. You have all of the shopkeeping functionality in the shopkeeper class, which is selling, bartering, whatever. But your goblin shopkeeper can't inherit from shopkeeper because that would make the goblin shopkeeper a human. Because shopkeeper inherently takes from human, right? Without a doubt, inheritance has its place in software development, brother. I mean, if that place is the dustbin, I'm kidding. It's not that bad. But in gameplay programming, it can cause problems. The thing with inheritance is, I think one level of inheritance, when you know something will only be one level of inheritance, it works, but then you can't guarantee that. So we're using something at work, like we're using extends in TypeScript, but it's actually like very useful because it's for API requests. So we make one base API request class, and then on top of that, when we wrap that API request class, then it's helpful because, like, oh, you are making API requests, so the repetition is over. You don't have to always do fetch, fetch, fetch. So anyway, the second problem is the misuse of cache. Two problems of engineering: not naming a variable and knowing when to uncache the cache. I don't know, something like that. In games, you commonly iterate over a set of objects multiple times per second, running methods on them every frame, correct? For example, your physics system might iterate over all objects that are subject to physics and call object.integrate dt. Dt is time, by the way. So, hmm. Updating their velocity, updating the position, velocity, and acceleration. So, traditionally, you'd have your big object that contains all of its state, correct? Including those needed for physics, and you'd call the integrate function on every object that needs to be updated, correct? In each object's integrate method, you access the object's position, velocity, and acceleration member variables. When you access position, it's pulled into a cache line along with nearby member variables. Okay. Why are we caching? Just because multiple frames can use the same, like if something's not moving, then I can understand caching the value. That's probably what they're going for. When you access position, it's oh, yeah, okay, okay. Some of those nearby member variables will be useful, velocity and acceleration, while others will not be. This is a huge range of the cache, and in an age where performance bottleneck is the time it takes for data to get from main memory to CPU's memory, it's a big deal. Okay, interesting. The fact that they're considering this part is insane, especially in the era of white coding, dude. Love it. The tides have been shifting into component-based design to solve the first problem. Looking at Unity, for example, all of the game objects are component-based. You start with a blank object that has only the default required transform component, and you add more components to the given object. Wait, and you add more components to give the object functionality. So the component basically gives the functionality to the object or the entity. But that hasn't solved the second problem, which is the cache, right? The second problem is solved by keeping all of the data that will be iterated upon regularly packed tightly into memory so that an entire cache line's worth of data can be loaded at once. We're going to read that again because I didn't really understand that. The second problem is solved by keeping all of the data that will be iterated upon regularly packed tightly into memory so that an entire cache line's worth of data can be loaded at once. And when the next item is iterated upon, its data is already in the cache. I don't really understand that, if I'm being honest. But that's okay. We can keep reading. This is solved by defining components as plain old data. Hey, let's go. Essentially, a simple struct with only the relevant data included. To continue the physics example, you might have transform with position, rigid body. I'm guessing there's a B missing here. Rigid body with velocity and acceleration, and gravity with the gravitational constant G mentioned. The physics system would then iterate over all objects that contain these three components, pulling in only the data it cares about into the cache. Oh, the physics system would then iterate over all the objects that contain these three components. So, if my object has these three components attached to it, it would only pull in the system itself would only take in those objects, and then you can have different systems which which like take into account different components and then work on those components. I think am I stupid to believe that first problem can be solved with overriding? But then how much will you override, right? Like if you keep overriding, and then imagine like especially for a game, you have so many characters, you can have so many like things, and if you keep inheriting and you keep overriding on every thing, then like from a code maintainability standpoint also it's just gonna like cause chaos. And the thing is like, let's say I'm pretty sure there's some performance boost, like second problem is for performance boost, right? So but other than the cache stuff also, I'm not sure if there's a performance boost in like something which is attached on the first level versus something which like keeps inheriting almost like a tree structure. So that is it. It can, if it's like not a big enough thing, I think overriding works. But I think if you know that it's going to be a big system, why kill your future self over it, right? So Unity is moving in this direction with the introduction of its own ECS implementation, bro. Imagine being able to implement ECS yourself. That's pretty cool. Brother, I don't really like the 1 second. Okay, we're back. We're so back. Are we so back? We're so back. In reality, the traditional concept of the object is gone. Okay. Instead, we have an entity. Oh, okay, which is simply an ID. Okay, okay. I think we can start writing notes. Entity is only the ID. Okay. It doesn't contain anything. Instead, the ID is used as an index into an array of components. Okay. An array is contiguous in memory. What games? Oh, game development. Yeah, yeah. Instead, the ID is used as an index into an array of components, and arrays are contiguous. An array is contiguous in memory, which lends itself well to being the data structure of choice. So the physics system might have a list of all entities that have a. So the physics system, now the system part comes in, might have a list of all entities that have these components, and use the entity's ID as an index into the transform array. And transform is a component which is over here. So array of components, for example, transform array into the rigid body array. And this entity's ID is used as an index in here. But I think we'll code it out so we'll understand better. So conceptually, it's all pretty simple. Okay. So conceptually, it's all pretty simple. An entity is an ID. A component is a struct of data. Okay, something to write. Component is a struct of data. A system is the logic that operates on the components. Interesting. System is the logic that operates on the components. Okay. The meat of this post will be on how to implement those three elements in a way that is simple, easy to understand, and easy to use. I set out to design mine with the following goals: relatively simple and understandable, modern C++. Nah, bro. We ain't doing it in C++, dude. Minimal amount of if conditions to avoid branch mispredictions. Minimal virtual inheritance to avoid virtual function. Okay, whatever. Okay, let's start. Let's start. Honestly, I think let's just call it ECS JS. Oh no, but oh man, I don't really want to do it, but it's fine. Um, brother. Okay, fine. Take it. I didn't really want to do it, but it's fine. Add types node, sure, why not? PX, PSC, yeah, okay, it's fine. Whatever. Uh, no. Okay, source best. I think this is something you can take and lib and types, right? Types you can remove. And we can go to package.json. We can be like, hey dude, this should be dist by the way. And you can put type as whoa, brother type module. Okay. We're gonna make a source index.ts. Okay. So, and we're gonna make a types.ts, right? Type entity is equal to a uint, right? So number. Entity is a number, and we can add in a comment here. Entity is just an ID. So its type is of a number. Okay. Okay. Const entity, max entities. Let's just put a constant. Bro, what am I doing? I swear, sometimes even I don't know what I do in AOM. Constants.ts. Export const max entities is equal to 5,000. Was it 5,000? Yeah. Used to define the size of arrays later on. The thing is, you have to do this in C++ because like static memory allocation. You could of course, yeah. The component. A component is almost as simple as an entity. Is just a struct with a small chunk of functionality related data. Okay, so we can come here. We can be like, hey, export type transform, and we say that vec3, which is a vector of 3 dimension, right? How do you represent vec3 in? Oh, okay. Yeah, position. Oh, is it? My bad. Wait, what? Did I just forget? Dude, what am I doing? String array. String array or number array? I think it should be a number array, right? This should only have 3 elements, I think. Okay. What is squat? And vec3 is scale. Scale also is a number array. And what is? I guess it's a number. Okay. Each component type also has a unique ID given to it. Okay. So that means export type component type is equal to a number. A simple type alias, like the type of the component basically, right? And max components is 32. Mac components is whoa, but my god, what's happening? I've forgotten how to dude. I'm also typing like I'm streaming after a while, but I've also like writing on my laptop after a while. I've been so busy with work, I've not been able to code my own stuff. You type so fast, sir. Thank you. Years of practice and pain. The signature. Since an entity is simply an ID, we need a way to track which components an entity has. Correct. which component an entity has. And we also need a way to track which components a system cares about. I choose the very simple approach of using a bit set called a signature. Each component type has a unique ID. Bro's old, dude. People are calling me Unk in real life. So, you know, we're getting old, chat. We're getting old. Anyway, which is called a signature. Each component type has a unique ID, which is used to represent a bit in the signature. What? What is a bit field? You turned 21. Oh my god. Crazy, bro. What is the. Is it aunt or is it unk? Like, multiple Boolean flags or small integers into a single byte. So you need a signature, right? Why can't I just. Let's see. It doesn't have to be perfect. We'll fix anything that comes up later. Uh, okay. As an example, Unk works. Okay, Unk it is. As an example, if transform has type 0, rigid body has type 1, and gravity has type 2, an entity that has those three components would have a signature of 0B111. What is B over here? Bits 0, 1, bits 0, 1, and 2 are set. Correct. But what is B? Huh? I get this part, but what are these two? A system would also register its interest in certain components as another signature. Then it's a simple bitwise comparison to ensure that an entity signature contains the system signature. An entity might have more components than a system requires, which is fine as long as it has all the components a system requires. I, I'm, I think I'm feeling a bit stupid, but it's okay. A bit set of max components, so that means 32 bits, right? Uh, okay, so this will be of the form zero of a bit set where the max length is of max components. Okay. Daksh, are we together? Are you also getting confused and feeling a bit stupid? Uh, the entity manager is in charge of distributing entity IDs and keeping record of which IDs are in use and which are not. Okay, that makes sense. We're going to make a class. All right. Okay. Um, I guess we can do that in index. We can like start support class entity manager. Bit would be an understatement. Fair. The entity manager is okay. Okay. I choose to use a simple queue. We'll make it an array where on startup the queue is initialized to contain every valid entity ID up to max entities. When an entity is created, it takes an ID from the front of the queue. Oh, okay. And when an entity is destroyed, it puts the destroyed ID at the back of the queue. Oh, dude, push and pop. Let's go. Okay, okay, okay. So what do we need? We need m available entities, and then we have create entity and destroy entity and set signature. Okay, okay. And what? Where is m available entities? I don't see. Is it like is C++ different? Then oh, there it is. Private variables, right? Okay. M available entities. So that would be like this: m available entities, which should be an array of entity. Am I correct? That seems correct. Then we have an array of signatures where the index corresponds to the entity ID. Okay, an array of signatures basically, right? And then we have m living entity count. M living entity count, which is of number, and then we have M signatures, which would be an array of signature array. Okay, okay, and then we have okay. So this is what we're gonna do. We're gonna be like, hey, when you create the entity manager for let I is equal to 0, I less than equal to max entities I plus plus um okay, m available entities dot push I, right? Is it less than equal to or less than? Yeah, less than is fine, right? What is your issue? Is wait, Shashwat did remind me. Oh, I know. Yeah, yeah, yeah. That's yeah. Okay, so that should work. That should work. And then we have create entity, and what are we asserting? M living entity, brother. Okay, too many entities in existence. If the current entity count that are living is more than the max entities, so actually we can do something like this. If you really want to over optimize it, function assert condition. Wait, if it is less. Oh, okay. Should throw. Yeah. Throw error. Just this is why I don't like variable name. Okay. Uh, if throw error, throw new error. Whoa! What just happened? Whoa! Message string. Message or give me more context, lil bro. Yeah, good enough, right? And we can export this. And then I can be like, hey, assert. Oh, there's an assert in node. What am I doing? Like in life? Yeah, let's go. What am I saying? If, hey, my M living is less than max entities. So if this is true, no, but I don't. If my living entity is less than my max entity, then I can create it, right? So not throw error, not throw. Oh, this is so bad. Like, I don't like this code, but okay. So basically, I'm saying that here, if this is 1 second, chat. Okay. We can worry about that later. Okay, wait. If this is true, means not through should be true. And if not through is not true, which it is, so true of not becomes false, so it will not hit that. Okay, I think that makes sense. We're gonna find out. Like we'll settle the bug if. And what is the too many entities in existence? Nice, I like it. Entity ID. Take an ID from the front of the queue. M available entities dot pop. Okay, take it from the front and then take it out, right? So that would basically mean const entity ID, which is of type entity, should be my M available dot pop is back, right? What is the thing to get it from the front? I forgot. Entries, values, reduce, splice, blah 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 blah. Oh, is it shift? Removes the first element from an array and returns it. Yeah. This is what I want. Shift. So I get the first element. Why am I popping? That's weird. Does pop in C++ means it gives me the first thing? That's what I would assume, right? No? Anyway, M living entities count plus plus. Great. And then I have return entity ID, which basically means that hey, I'm returning my entity from here. What is your issue? Type number undefined. Uh, there you go. In fact, yeah, it should. Yeah, that's correct. Pop is supposed to give top or back of the thing. I like that's what I'm supposed to get the first one, but why am I removing the back one if like that doesn't make sense, right? Like for example, think of it like this. The idea is basically let's say you have one, two, three, 100. If I 1,000, whatever. If I create an entity, then basically my first entity will have my ID of like is equal to 0. And then when I create my second entity, it should have my ID of 1, right? But to get the ID of 1, I need to remove this from the array, right? So like I create my this thing, I pop it out, like I take out 0 from the array. Then when I have 1 over here, I take out 1 from the array. Now I have 2. And when I delete an entity, let's say I delete this, then it needs to go back over here. And then when I delete this needs to go back here. So I'm guessing that's what we're doing. Uh, that's what we'll figure it out. We'll figure it out. I think it's fine. M living entity count 0, so that you stop complaining because you are so complaining. And then we have destroy brother. Let's not. Uh huh. Brother. Can we? Yeah. I just want to like. कौन message कर रहा है? Okay. We want to delete an entity, and I guess we have to pass in the entity ID. Yep. Entity, which is of type entity, and we don't return it, so that's fine. And assert if entity is less than max entities, entity out of range. Oh, if this has to be true, if it's not true, then entity is out of range. Correct. M signatures entity dot reset. Interesting. What does reset do? Where is Claude when you need it? Actually, we can just spin it up here, to be honest. Here's the context. I'm making an ECS to in general from this blog. I want you to help me understand concepts when I ask you questions. Do not give me any code. The blog writes the ECS in C++, but I'm writing it in TypeScript. Let's begin. I'll take a quick check before we dive in. Do you want to start from the very top? Why is it different, or have you already read part of the blog and want to jump in? I'm currently implementing the entity manager part. In that, I want you to help me understand two things. What is the role of the signature exactly, and then what does dot reset do under delete entity mentioned in the blog? What is the actually what does it do, right? Yeah. What is memory doing, by the way? I have not. You want to try memory? Open a memory file in your editor. Okay. So what is it saying? Each entity in this design is really just an integer ID. It has no data of its own. So how does the system know this entity has a transform and gravity component but not a rigid body? That's what the signature answers. Think of it as a fixed width bit mask, 1 bit per component type, not per component instance. Okay. Uh, if transform is assigned bit 0 and gravity is assigned bit 1, then an entity with both components has a signature where bits 0 and 1 are set. Oh, so you add in the type ID, or sorry, the component type in the bit mask. Is it like that? The entity manager keeps one of these signatures per living entity ID. Okay, so the arrays correspond to each other basically. That's what I'm understanding. This signature is to join wait, this signature is the join point between three managers. Component manager, the component manager is what assigns each component type its bit position. Oh, so it is correct. Whenever a component is added or removed from an entity, that entity's signature gets updated. 1 bit is flipped. Why is it flipped? Oh, 1 bit is flipped, not like all of them are flipped. Okay, interesting. Uh, the system manager gives every system its own signature. Every system its own signature. The set of component a system cares about. Got it. Got it. Daksh, are you with me? Are you with me? Are we getting this? I think I'm somewhat getting it. To decide does entity X belong in system Y, it compares entity X's signature against system Y's signature. So the signature is essentially a cheap fixed size answer to what shape of entity is this, and comparing two fixed with bit masks is a lot faster than checking a list of component types. Correct. What reset does, since the signature is a bit set, reset just clears every bit back to 0. Oh, okay, and we're deleting the entity, right? That makes sense. Okay, but where are we setting the entity? We're not setting the. Somehow, do you want to do something crazy? Do you want to make it a string and then like do bitwise operation on the string? Can you do bitwise operations in TypeScript? Um, bit set in TypeScript? I don't think it's a thing. Is it a thing? Oh my god! Wow. Oh, like this. Hmm. Interesting. Interesting. User auth permission dot read. Okay. String iteration on string iteration, right? Let's go. Let's do that. It's fine. It's fine. Like if it doesn't, if it's fine if you don't first try it. Basically, that's okay, right? Uh, yeah. Okay. 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 So we just add in this thing. It'll be like 000 or 001 or 010, etc. Right? And the signature then represents what all component types are present. So, for example, if an entity has a signature 001, so it doesn't have two components, but it has one component. I think that's what it means. I think. Okay, anyway. M signature entity dot reset. So that means I'm being like, hey, M signature of entity is equal to that, right? And then I'm pushing it, uh, dot push the entity back, and then I'm doing minus minus. Hey, let's go. I think we're so back. Yeah, we're so back. Okay. Okay. So I'm getting messages from works like the US team is up right now, right? So that's what's happening. Dude, it's already 10:47. How long have you been streaming? 50 minutes and we've only got an entity manager? Brother, too slow. Set signature. Let's go. Let's go. Um, set signature. Brother, you're so late, Shashwat. You're so late. You're so late, dude. Dude, you're so late. Oh my god. You're so late. Shashwat, you're so late. We're so back. We're so back. Dude, I love this song so much. I've been listening to it the whole day and oh my god, we're so back. We're so back. We're so back. Oh my god, I forgot how to type, dude. 100%. 100%. 100%. I want the signature of an I want the signature of an entity, right? So I'll be like, hey, give me the signature of the entity. No, no, no. Okay, Shashwat. The blog is in C++. I am implementing the same thing in TypeScript so that I understand. Oh, dude, by the way, Daksh, we did do a stream where I implemented a linked list in C and Shashwat basically had a panic attack at like every 5 minutes. Listen, but it's fine. I think the language doesn't matter right now, and I think it's completely fine. Assert entity needs. Actually, this is the same thing, right? Yeah, I can just take this. Yeah, entity out of range, return. Yeah, signatures of entity as string. Actually, as signature. As fine, whatever. We know it's a signature another day. The stream is there right now, right? Yeah, yeah, it's there. I thought what I opened the stream and saw CPP. I couldn't believe my eyes. I one day, dude. We can rewrite this in C++ also, honestly, but like later, not now. So also, Daksh, I think we're so back. Wait, did I do something wrong? Where is set signature? Oh yeah, and then I'm doing hey. Wow, my eyes, dude. M signatures of entity is equal to signature. So cool. Oh, 150 subs, dude. I'm so surprised on it. I was on 146, and then K6 wala stream. Apparently, YouTube says that got 4 more subs. We'll take the win. We'll take the win. The component array, dude. Last 1 hour, this is only what we've gone through, and there's this much. So crazy. Anyway, we can continue with the weekend. That's also fine. Okay, we need to create a data structure that is essentially simple array, but is always a packed array. What the hell is a packed array? Okay, meaning it has no holes. If an entity is just an index into an array of components. Oh, this is what it means, right? An entity is an index into an array of components. So basically, at this position, like in a signature array, my entity is acting as the index. So when I say, okay, this entity, it means in the array that position represents the signature for that entity. Okay, not bad at all. So we're basically like syncing up states manually. Like a lot of states are there, and we're saying that these states correspond with each other, and we are the ones handling that correspondence, if that makes sense. Okay, meaning it has no holes. If an entity is just an index into an array of components, then it's simple to grab the relevant component for an entity. But what happens when an entity is destroyed? That index into the array is no longer valid Very correct. Remember that the entire point of ECS is to keep the data packed in memory, meaning that you should be able to iterate over all of the indices in the array without needing any sort of if valid checks. When an entity is destroyed, the component data it had still exists in the arrays. If a system were to then try to iterate over the array, it would encounter stale data with no entity attached. Correct. For this reason, we need to keep the array packed with valid data at all times. Correct. I chose the guy. I chose to solve this problem by keeping a mapping from entity IDs to array indices. Oh, and then, okay. When accessing the array, use the entity ID to look up the actual array index. Then, when an entity is destroyed, to take the last valid element in the array and move it into the deleted entity spot. Why? And update the map so that the entity ID now points to the correct position. Oh, okay. Okay, I get it. Somewhat. Classic, brother. Data oriented programming, dude. Crazy. And update the map so that the entity ID now points to the correct position. There is also a map from the array index to an entity ID so that when moving the last array element, you know which entity was using that index and can update its map. Okay, let me demonstrate the process visually because try as I might to make the code understandable, it's still cleaner in picture form. Oh, okay. Let's assume that the max entities is set to 5. The array starts out empty. There is nothing in the map, so the size is 0. Okay. So we have an array, we have a map, we have another map, and the size is 0. Okay, are we ready? We then add a component with value a to entity 0. Add a to entity 0. And a is a component. Okay, component with value a to entity 0. So I'm saying that, hey, this is my components. Entity 0 has a. Entity to index. Entity 0 data is at index 0. So this is the value. Index to entity. Index 0 holds entity zero's data. Okay, there's two maps. Interesting. We then add a component with value b to entity 1. Entity 1 maps, okay, 1, correct. Okay. So entity 1 has component value b. Okay. Perfect. This should, correct. This seems right. We then add, okay, 4 components, 4 entities. Let's go. So far, so good. Everything is packed into memory, but then we delete value b from entity 1. To keep it packed, we move the last element d into the spot occupied by b and update the maps. So without looking into it, what would that mean? Let's take this. We delete this part and we replace it with this. So that means my entity, which is d, so 3, should point to 1. So this should be 3 is to 1. And then 1 is to 3. And then b just gets deleted. Let's see if you're right. Entity 3 maps to index 1 and what? I think I'm the goat. I think that's called first try. That right there is called first try. Okay. Good job. We then delete the value d from entity 3, moving the last element c. So this becomes goat went on a no, dude. So that means 2 is to 1 and 1 is to 2 and d gets removed. And we have AC. Somebody touch my spaghetti. Anyway, finally we add value e to entity 4. So that means ACE and then 4 is to 2 and then 2 is to 4. So entity is array of components and index is array of entities. Where are the signatures here? Wait, what? Okay. No. Entity itself. Okay, let's pull out this. Let's pull out our old friend. Scalera.com. I don't even, that's a Pipecast, dude. I need to work on Pipecast also. But anyway, okay. So here's the thing. Entity is an ID, right? An entity is basically, my God, ID. It's a string or a number, whatever the type of your ID is. Entity and ID are the same thing. Now, what you do is essentially in a visual, this is one way to represent it, is basically you attach your components to the entity, right? So this is component A, right? So, what do you say? If I make this a group and then I come here, no, not that, control D, yeah, right. Now, let's say this is entity 2 and this has the component B attached to it. And let's say this is entity 2 and this is 1, right? So you are attaching a component to the entity, right? This thing is attached to the entity. Now, in this specific blog, not this one, although what a blog. In this specific blog, what they're doing is they are making an array, like, wait, yeah, they have an entity manager. Actually, wait, how do I explain this? Okay, they have an entity manager. What is this responsible for? They are checking three things. One is how many living entities are there in the system, not in the system, but just how many living entities are there currently, the count of it, all the entities. I'm just gonna, all the entities and all the signatures of the entities. What does this mean? This means, what is a signature? Signature is a bit field, right? Which means, let's say 0, 1, 0, where the values of this correspond to this thing. I'm just going to delete this part. No, no, no. Stop it. Stop it. Okay. Now, when it said 0, 1, 0 over here, what does this mean? It means that 0 over here could mean transform component or the type of transform component. Over here, this could mean gravity component. Over here, this could mean rigid body. So basically, let's say I have 100 entities, right? One entity has the signature 0, 1, 0. That means that this entity only has gravity applied to it. It doesn't have the transform component. It doesn't have the rigid body component. Let's say I have another entity, my second entity. I have 1, 1, 0, which means I have the, let me just remove this thing. Yeah, which means I have this entity, second entity, it has the transform component, it has the gravity component, but it does not have the rigid body component. Right? And then some entity 3 can have all of them, some entity 4 can have none of them. So the signature basically says that, hey, this entity contains these components attached to it, right? So this thing that we've done over here is being represented by the signature. And when they say that the entity acts as an index to the signature array, what that means is, let's say I have an array, right? This is my signature array. Okay. When I'm using entity as my index, what I'm saying is that, hey, sig array of entity gives me, what do you say? Gives me some 0, 1, 0, 0, 0, 1, 0 value, right? So what I'm saying is that, hey, in this whole array of signatures, in my whole array of that's not an array, but whatever, of whatever value, 0, 1, 2, 3, whatever, the index, let's say I have an entity with an ID 5. So my fifth element over here, or sixth element rather, My sixth element over here with my entity ID 5 will give me the signature of entity ID 5. So I'm saying that, hey, if I want sig array of my fifth entity, I will use its entity ID as the index to get the signature of it, which can be 001, let's say. You with me? Are you with me, Daksh? Are we understanding? I know YouTube has a lag, so I'll just wait for you to respond. Oh, okay, we're understanding. Great. Okay. Now is an array of components and index is array of entities. Okay. Now this is where this part comes in. This particular section is about the component array. Now we're saying that, hey, this was only all this that we did. It was only under the entity manager where we're saying that what are components an entity can have. Now comes the actual component part. What is a component? Right? A component is basically a struct with some fields. Now we are saying that, okay, uh, what is it saying? We need to create a data structure that is a simple array but is always a packed array, meaning it has no holes. If an entity is just an index into an array of components, what that means is that, hey, if I have an array of components, which I can, let's say I have an array, brother, I have a component array, right? If I do comp array of entity, and this is this is what I think is happening. It should give me the component of the entity attached to the entity, right? Like this entity has this component or these components basically, and because component is a struct, it will give me the component is a struct. It will give me the values of like the component. Basically, that's what I think that's what it's saying, right? And this whole logic that's happening is to basically solve the second issue, which is the cache issue. To say that we need a packed array. We don't need any array with like null values or like stale value, right? So this is to basically address the second problem, this whole approach. And to maintain that second, like to maintain the array as a packed array, we're saying that we're going to keep two maps, right? So over here, if I'm basically, it's a way of maintaining state. That's basically it. Like I'm saying that, okay, if let's say tomorrow I remove something from the array, let's say, okay, wait. Yeah. Okay. Let's say I have A, B, C, and this is for entity 0, entity 1, entity 2, right? So my above thing is my component array, and this thing is my entity IDs or my entity array. Let's say I remove 2, or let's say remove B, let's say remove 1. Let's say delete my entity 1 from the system. So I should technically, what will happen is I will have ABC in my component array, but in my entity array, I'll only have 0, 2. Right? And now let's say I iterate over my component array and I be like, oh, I still have B, and over here I have 2. So that means my entity 2, entity ID with 2 has the component B, which is not correct, right? Or no, that's the wrong way to put it. Entity has the index to the component, so we still get the correct component. But the thing is, this is an extra element in the array, so we have stale data. Now we're saying that if we are removing an entity from here, we should also remove the component over here. So to address this, what we're doing is we're keeping a map. How do you represent a map? Okay, record in TypeScript basically. Oh, my brother in Christ. We are keeping a record saying that, hey, the entity ID maps to the index of the array. So what happens is that, yeah, we say that, okay, my entity ID of 1 corresponds to my index of 1 in the component array. This one is in the component array. And this one is my, what am I doing? What am I doing? Like in life, what am I doing? You know what I mean? Yeah, okay. This one is my This one is my index of the component array, which points to B. This one is my entity ID, which is of B. This if I this one, yeah. So I'm saying that I'm going to create a map or a record, which basically helps me understand that okay, this entity ID corresponds to this index in the component array. Now, what happens is when I delete my entity one over here, I can be like, hey, this thing is deleted, but how do I actually do that in the array? So what I'm doing is, in this logic that they've mentioned, what they're doing is that they're going to put two, and let's say there is a actually it's fine. Let's say there's four elements, right? Over here. So let's say there's three. Let's say there's D. uh, A, B, C, D, and this is 2, 3. Okay. Now, basically, I've deleted my first entity ID, right? And makes sense now. Got the hang of it. Yeah, it's not like inherent, like intuitive, but like somewhat makes sense. So now I delete this entity, my entity ID 1. The logic they're going for is they're saying that hey, this 3, which is the last element, it should now take the place of 1. So now the order will be 0, 3, 2, right? But over here, I still have this thing. So I need another map which helps me understand that okay, I've replaced the last element with my first one. So this is also entity. So this is the index to my entity ID, which basically which says that hey, now my first element, my first index in what in the component array maps to 3, which is the entity ID. So my last entity over here in the entity array comes over here in the sorry D should come over here, and this should just be that. Yeah. So now I'm saying that okay, my D has come here because now I'm assuming that my 3 has taken the place of 1. Does that make sense? Like kind of. I know it's not good explanation, but like we're rolling. Like the whole point of the stream is to understand that. I somewhat get it, somewhat. So components remove and added while maintaining density. Okay, I'm not gonna lie. I think this is a good place to stop the stream, and it's like 1 second. Anyway, we should continue in the weekend because I'm tired and information is not getting in my head. So this is what we're doing. I still need to understand this better. The stream was playing in the BG. Oh, okay. Oh, we're stopping the stream. Like I feel stupid now, but it's a good feeling of stupid. Like I think I learned something today, and like I think I need to read this like 5, 10 times to like actually get in my head, and we'll implement it also. Like this thing we're going to implement it. So when we implement it, I think we'll have a better idea. But this is what I get. This is what the hang of it is. So anyway, I'm gonna watch Attack on Titan now. Probably make something to drink, or we're just gonna drink water. Probably, you never know. Water, dude. Anyway, I'm going to stop the stream, but thank you for joining. Thank you for Daksh, Shashwat, even Tulip. Thank you for joining. Thank you for staying. I shall end stream. Brother. Nah, brother. You're hearing things. That's selective listening. Yeah. Anyway, chalo. I'm going to close the stream. Thank you for joining. See you in the weekend. Bye bye.